Hi everyone, welcome back to our channel. Today we are going to do this MATLAB simulation of ABCD parameters. In this given network, here you can observe here, this is a T network. The series branch is 1000 ohm and next series branch is 1000 ohm and shunt branch is 500 ohm, and we need to perform the ABCD parameters. Here you can see here I had first evaluated A as well as C, and next I will evaluate B as well as D. So in order to perform this, we have to construct this diagram. Now let's try to see how to design this in MATLAB. Okay. So here to excite it, we require one voltmeter, and to find the current I1, we require one ammeter. To find the output voltage, we require one more ammeter. Let's try to see here how to construct here. Okay. So the process is just click on the MATLAB. When you click on the MATLAB, a window will be viewed like this, and at the top you can see here I'm moving the cursor. Simulink is there. Just click on the Simulink. On this Simulink, click on the blank model. It will be opening an blank model. Okay, so it will create a new simulation file, and it is showing that creating an model. Okay, so it will create one model. So it is creating a model, and you minimize the MATLAB window. And what we need to do, let's try to drag it to the left hand side. Okay, so I'm keeping it in left hand side, and the original circuit I'm keeping in right hand side. Okay, so keep this main block in right hand side. Okay, so you can keep the two halves, then you can understand better. So increase left side as well as right side, where the window will be very clear. Okay, so now we can see here. So we need to design this. You can see the basic elements. What we require is one voltage source and three resistors and voltmeters and ammeters, and you require an power GUI. So where to have these elements is, click on the at the topmost you have an library browser. Click on the library browser, and here just you scroll down. Here you'll be having a Simscape. Okay, so in Simscape you go to electrical. In electrical you go to specialized power system. In specialized power system you go to electrical sources. You have a DC source, drag it and keep it in an untitled simulation. Okay, and here in the fundamental blocks you require an power GUI. Keep this power GUI also here. Okay, and this power GUI generally have to keep at the top, and this is the voltage source, and we require the elements. So electrical sources elements. In this element, use series RLC branch and insert here, and you require the measurement of voltage and current. For this measurement, drag this ammeter, and the next element, drag the voltmeter. Okay, and we want to see the output. In order to see the output, go to sync, use the display button. Okay, that's all. So as per the requirement, we'll go inside which element we require. Okay, so voltage source, voltmeter, and we require one mathematical operation. Okay, so click on the simulation and go to mathematical operation. Here we have divide option. So drag it and pull into the untitled. Okay, now let us use this as a reference to design this one. Okay, so now see the elements. This is the voltmeter. So use this voltage source, keep this GUI here, and we need to construct this T network. Okay. So here also double click on this series RLC branch and change the branch type as R, and just click on apply as well as OK. Double click on it and write down this value as 1000 ohm. Okay. So the value of this resistor is 1000 ohm. Click on apply as well as OK button. Okay, so here you got a series RLC branch. Okay, and you need to construct the T network. Now let's try to keep the remaining branch also. Just use Control C button, and here also use Control V button. The network will be pasted. And you want a shunt branch, just click on this block and just use a Control C button and use a Control V button. It will be pasted. Just rotate. Just use Control R. Okay, it will be rotated, or all the options will be available in in the format rotate clockwise, just rotate. And once again go here, now go to rotate and flip, just use rotate, automatically it will be rotated. If you require in reverse, once again you can use rotate, just rotate clockwise. Okay, so like this you can change whatever the direction you require. And now to the source we are going to connect, and you can see here we require I1 as well as V2. I mean, two voltmeters at input port and output should be open circuit. Okay, so that's why use 1 over voltmeter and connect here. We require 2 voltmeters, connect the 2 voltmeters and 1 ammeter. Okay, so 2 voltmeters and 1 ammeter, two at input side. Okay, so where is that ammeter? Take this ammeter and connect the ammeter here. Okay, now let's try to use the connections very simply. So just use the positive terminal and connect to ammeter positive, and just connect from the ammeter negative to the resistance. Connect these two resistance in series connection, connect these two in series connection, and negative to negative you connect. And you can see here output port is open circuited. Okay, so just copy this branch and paste here and give the connection. Okay, in order to show it okay, open circuited, what to do is just drag this element and connect to this terminal and just remove this element. And now you just drag it, where you can see here output is open circuited. Just you can write a comment here, output is open circuited, output port is open circuited, that is I1 is equal to 0. Just add. Okay, so now as soon as you make it open circuited, the resistance you have to inject the resistance, and whenever it is open circuited the voltage will be available at this point. Just connect the positive to positive, connect negative to negative. So connect negative to negative. So if it is showing black, it is correct, but I want to show you it is connected in parallel. Okay, so now let's try to see the output. Just connect the display to here. Okay, so at the display you write down, this is nothing but V2. Okay, and this is nothing but V1. So connect positive to positive. If it is a black, then only it is an proper connection. Okay, so now again Control C, Control V, just paste here, and this will be acting as V1. Okay, so now let's try to define the elements. This is an 30 volt source, give it as 30 volts. Just click on apply as well as OK button. This is a 1000 ohm resistor, double click on it, write down it as 1000. And this is a 500 ohm resistor, double click on it and enter this value as 500. Just click on apply as well as OK button. And this is an 1000 ohm resistor, double click on it and write down it as 1000. Okay, so with this the construction of the circuit is completed, and here we require to connect an ammeter also. Okay, so Control C, Control V. Okay, so this will be acting as an I1 current. Okay, so now let's try to go with the basics of how to write down. Okay, so now we are doing these ABCD parameters. The basic equation of ABCD parameters is V1, I1 or input port, output port is V2 and minus I2. Here current will flow in opposite direction. So the theoretical calculation and hardware will be leave in the card. You can view the theoretical and hardware also. So now we are writing the equations of V1 as well as I1. Okay, so V1 is equal to A V2 minus B I2, and I1 is equal to C V2 minus D I2. So I require the values of A and C. What I have to perform is I have to make I2 equal to 0, which is nothing but output port is open circuited. Okay, so when we make I2 equal to 0, these two terms will become 0. Therefore you are going to get the value of A is equal to V1 by V2. So voltage by voltage, no unit. This is called reverse voltage gain. you're going to get the value of C is equal to I1 by V2. Okay, this is how we have to make the first step, I2 equal to 0. And second step, we have to make V2 equal to 0. V2 is 0 means output port is short circuited. So output port is short circuited. Automatically this will become as 0. Therefore the value of B is equal to V1 divided by minus I2. Here you are going to get the units in ohms. Here also you are going to get the units in mhos. And the value of B you are going to get it as I1 divided by minus I2. Current by current, which is called reverse current gain. Okay, this is called reverse voltage gain, and here you're going to have no units. So this, by two steps you have to design. First I'm making I2 equal to 0, and I'm finding V1 by V2 as well as I1 by V2. Okay, just remember this. Now we are going to find out a value, which is nothing but V1 by V2. Okay, so whether the simulation is running or not, just click on it, so it will show the values are correct. So you can see here it is 30, and here also 10 and 0.2. Okay, now we require V1 by V2. So now this is V1 value. So just connect V1 here, connect V1 here, and just connect V2 here. Okay, so this is going to give us the output. So it is showing red color means you need to redraw it again to make the connections perfect. If it is a black color, the connection is perfect, and you are going to get the output. Just copy it and paste here, and this will give the value of A. So the value of transmission parameter A is equal to V1 divided by V2. Okay, V1 by V2. And next one we require I1 by V2. So I1 by V2. So just use this block. Just use Control C button, and here also use Control V button. It will be pasted. So here you are also going to get the output Control C, Control V, and this is not. This is going to give the value of C is equal to I1 by V2. I1 divided by V2. Okay, so here is nothing but no units. Here is nothing but I by V. You are going to get it as mhos. So I1, where is I1? So this is the value of I1. Okay, so connect to the value of I1, and next one at the denominator we have V2. So this is also the same denominator. Okay, you can see both the denominators are same. So after connecting this, just run it. Okay, so therefore you are going to get the value of a value as well as d value. So the d value, I mean a value as well as c value, we are going to get from this simulation. Okay, so let's try to see here. The a value you have to get it as 3, it is correct now, and c value is 0.02 mhos. Okay, so this c will be in terms of mhos, and this A will be voltage by voltage. There is no units. Okay, so successfully design the first part, which is nothing but V1 by V2 and I1 by A and C. Now the same diagram, but output port you have to make it as short circuit, and we have to find out 2 ammeters at input port and output port and V1. Okay, so V2 should be short circuited. Okay, so now let's see your circuit diagram. The next circuit diagram. So this is the circuit diagram we want to construct right now. Okay, so when you see this diagram, output port should be short circuited. Just drag those elements and keep here. Okay, so now see our simulation. So now you can use and drag and place. So just copy the source. Okay, just construct the network. Control C, Control V. Okay, Control C, Control V. Okay, and next one Control C, Control V. 3 elements are available, and we have to make output port should be short circuited. So output port is short circuited. OUT, output port V2. You have to make V2 equal to 0. Okay. So when you make V2 equal to 0 here, then output V2 equal to 0, which is nothing but short circuit. So there is no need of voltage source. Just click on annotate, you will be getting this network here. And V2 should be short circuited, means just connect this to this, and this you have to short circuit. That's all. This is called short circuit. So now output is short circuited, and what are the currents we require is I1 and I2. So in order to have the current at input port, just copy this current source and place here. Okay, just click on this block, just use a control C and use a control V here, you'll be getting this block. And here also you require the current, therefore we'll remove this link and we'll find the current as control C as well as control V. Okay, so we require I1 and I2. Okay, here you can see here I1 and I2. Okay, so just connect this to this one and connect short circuit through an ammeter and negative to 0. Okay, so now this block is completed and we need to exit. So output is short circuit, but input we have to apply the voltage. So from positive to positive we connect here, negative to negative we connect here, and this is the value of 1000. This is already there. This is 1000 ohms, this is 500 ohm, this is 1000 ohm. Okay, you can label there also. Okay, so you can label it as a 1000 ohms. Now we have to see the output, so now just copy it, control C, control V. Okay, so then you are going to get the current I1, and the same you will be getting the current I2. Okay, just connect to the output, you will be getting the current I2, and we require the input voltage. Okay, so in order to get the input voltage, here you can see here it is a 30 volts. Just copy the source here. Okay, so copy the voltage source, connect positive to positive, negative to negative, and check the voltage. Okay, this is nothing but V1. Okay, this will give V1 input voltage. Okay, so now let us try to do the. So here we require, you can already see in V1 by I2. Okay, so here you can see an improper connection is there, just delete it and connect it again. It's all very simple. Sometimes it creates a problem while doing simulation only, nothing issue. So now all the parameters are good, just run it. When you run it, you are going to get I1, I2 and V1, but we require V1 by I2. This is V1 by I2. Okay, so just use this summer, just use control C and paste the value here. So if you want to move the complete diagram, the technique you can follow is so just copy all the elements and hold on the blocks and just drag it down. Okay, automatically the complete network will be moved on. Okay, so now we require V1 by I2. So where is V1? So this is the value of V1. Okay, so first connect here, you require scope, just copy this and paste here, synchronize both. Okay, and this is going to give the output which is nothing but B. So the value of transmission parameter D is equal to V1 by I2. V1 divided by I2, polarity is there, nothing to bother, just you can leave. So just you can take the same block, you copy here and paste here, and this one more block you copy and paste, and here we are going to find out the value of D. So D is equal to I1 by I2, I1 divided by I2. Okay, so therefore the value of D is nothing but no units. Why? Because current by current. Okay, just connect this to this one, later we will connect this one. Okay, so here V1, so we already connected V1, so this is the V1 value and this is nothing but I2 value. Where is I2 value? Here it is there. Okay, just connect the I2 here. With this we calculated the B value, and D value is I1 by I2. So where is I1? So this is the value of I1. So connect I1 to I1 is this one, and this is nothing but I2 value. Connect I2 to the common value. Okay, denominators are common. Just run the simulation. So you can see here the original diagram we constructed. Okay, Just run the simulation. We will be getting the value of B is 4000 ohms, which is nothing but 4 kilo ohm, and D is 3. So this is what the procedure of designing an ABCD parameters in MATLAB. Okay, already in the just you can if you want this same content, you can take from my MATLAB also. In the MATLAB also same search you can do, and you can get the original simulation there. And now, so this is how to find out A value, B value, C value and D value. Remember, B will be in terms of ohm and reverse it will be in C, and this will doesn't have any reverse voltage gain and reverse current gain. It doesn't have much weight. Okay, so if you feel my explanation is good, please like the video and share with your friends those are want to learn the simulation. And if you have any doubts in the simulation, let me know in the comment section. If you want about the hardware, or if you want about the theoretical also, I will attach the video, and I will leave all this synchronized one. And if you are watching my channel for the first time, subscribe to my channel with the name kvthulasi. Okay, so this is a free channel for the development of students and faculty. So thank you for watching. We'll meet with another beautiful video. Yours Ram.